Hi, I'm Miss Hearn. If you like this video, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Miss Hearn Mathematics, for more math videos.
We're taking the limit as x goes to infinity, x plus 2 over x minus 1 to the x. So let's think about what type of form we have here. So what happens to x plus 2 over x minus 1 as x goes to infinity? Whenever we have a rational function, remember the highest power? 1. That's right. The coefficients of the leading terms, which have the same power, are 1s. So this is just going to go to 1. And then this guy is going to infinity. So this is a 1 to the infinity indeterminate form, which is why we're going to use the technique for power forms. So the first step for a power form is to give a name to the limit we're looking for. So we're going to let y equal the limit as x goes to infinity of x plus 2 over x minus 1 raised to the x power. And then what's the next step? That's right. So we're going to basically take the natural log of both sides, and then we're going to bring the natural log, as you said, into the limit, which we can do because natural log is continuous. Okay, and then we're power rule, exactly. Bring the x out front of the natural log. So now we know x is going to infinity. We know this inner part is going to 1, but the natural log of 1 is 0. So this is an infinity times 0 indeterminate form. And of course, that's a product form. So we want to rewrite it as a quotient. We have the natural log of y equals the limit as x goes to infinity. Now, how can we rewrite this as a quotient? That's right. So we have the natural log of x plus 2 over x minus 1 over 1 over x. So now it's a 0 over 0 indeterminate form. So we can use L'Hopital's rule. That means that natural log of y equals, by L'Hopital's rule, the limit as x goes to infinity of the derivative with respect to x of the top over the derivative with respect to x at the bottom. And the reason why I'm writing it this way is because I'm going to go off to the side and figure those out. So let's figure out the derivative of the natural log of x plus 2 over x minus 1. It would be 1 over the inside times the derivative of the inside. However, taking the derivative of the inside is going to include a quotient rule. And there is a little cheat that you can do to make it a little simpler. We can use rules of logs, so it's not as complicated. Okay, so then that's going to be 1 over x plus 2 times the derivative of x plus 2, which is 1, minus 1 over x minus 1 times 1. So 1 over x plus 2 minus 1 over x minus 1. And then what's the derivative of 1 over x? Yes, good. Negative 1 over x squared. So let's fill that information in over here. So we have the limit as x goes to infinity of 1 over x plus 2 minus 1 over x minus 1 over negative 1 over x squared. All right, so we can't take the limit at this point because we get 0 over 0. So we have a little bit of algebra to do. Let's go ahead and simplify this complex rational expression by multiplying by each of the denominators in the top and the bottom. We have to distribute this to here, to here. So that's going to be the limit as x goes to infinity of, we're going to have x squared times x minus 1 minus, we're going to have x squared times x plus 2 over, in the denominator, we're going to have negative x minus 1 x plus 2. So I'm gonna keep it in factored form as much as possible to see if anything reduces. So for the moment anyway, I'm gonna factor out an x squared, which is gonna leave behind x minus 1 minus x plus 2. So that's going to be the limit as x goes to infinity of x squared times -3. So -3x squared over negative x minus 1x plus 2. All right, so the negatives cancel, but that's about it. So to find this limit, we're going to need to multiply out the denominator. So we're going to have the limit as x goes to infinity of 3x squared over x squared plus x minus 2. And now we can just focus on the highest powers. So it equals 3.
I hope you found this video helpful. If you did, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Miss Earn Mathematics, for more math videos.